Hey everyone, before we dive into Jupyter Notebooks, I would like to spend a few minutes revisiting what we went over in the last video, where we ran Python script within VS Code. As you can see, we have been playing with this simple Python script here, and on the lower right corner of this window across the status bar, you can see we selected the Python interpreter that we wanted to use to run this script. And this Python interpreter is located under .first project env, which is the virtual environment we created directly under our project. And we ran the Python script by clicking on this run Python file option on the upper right corner of this VS Code. And the moment we select this, what VS Code would do is it will start a pre-configured PowerShell session within it. Right, and as you can see, this is a PowerShell session with a few things configured by VS Code to make sure that it uses this Python interpreter we selected on the lower right corner to execute this script. If you look closely, there are three things which VS Code does the moment we select run Python file. First, it activates the base environment, which is our base Anaconda environment, and then it activates the environment where our selected Python interpreter is located, and after that it finally executes the Python script. But these first two steps are actually redundant, because all we want VS Code to do is run the Python file using this interpreter that we have already selected. So these steps are just redundant, and we don't want VS Code to run these steps by default before it runs the Python file. Now, in order to deactivate this feature of VS Code, we can go to settings on the lower left corner and go to settings. As you can see here, VS Code allows us to apply our settings to different scopes. For example, any modifications that we make to our settings under user would apply to every instance of VS Code that we open. Whereas if we wanted our settings to be specific to the project that we are working with, then we can make them under the workspace scope, and they would not apply to a different instance of VS Code. For us to deactivate this feature, we can search for Python activate, and you can select Python here, and you can see this option, right? Activate Python environment in all terminals created. So we can just uncheck that, right? And we can delete this to start a new PowerShell instance. When we run the Python file again, it would not activate the base environment. It would directly run the Python script using this interpreter, right? As you can see, it directly ran the Python script. Okay, so let's get started with Jupyter Notebooks. And there are two different ways you can create Jupyter Notebooks from within VS Code. The first one is where you enter Ctrl+Shift+P, and that takes you to the command palette, and you can already see this option, right? Create new Jupyter Notebook. And if you can't see it, then you can just enter Jupyter, and it will be one of the first options that you can see within your command palette. So you can just select this create new Jupyter Notebook, and as you can see, it has created an untitled Jupyter Notebook. You can save it, you can enter Ctrl+S, and it will take you to your folder structure, and you can name it first notebook. You keep the type as JSON because that is how Jupyter source file is saved on the backend. So we'll just save it now. You can see the Jupyter Notebook within your folder structure. Another way, which is what I prefer, is you can simply create a new file from within your folder structure, and then you can just name it second notebook. And this time, instead of using py as an extension, we'll be using IPynb. Enter. Right, and that creates another Jupyter Notebook. Now let us do a quick overview of Jupyter Notebook experience in VS Code. So what you are seeing here is a code input cell. This is where we type our code, right? So in this case, for example, if you want to print hello world, we'll be typing that within our code input cell. And once we execute it, you'll see its output appears right below it within a code output cell. So before we execute this line of code, notice that Jupyter Notebook has already assumed my default programming language to be Python. And if you click on that, you will see that it does offer multiple other programming languages as well as scripting languages, including SQL, that you can use with Jupyter Notebooks. And then there is the select kernel option, which allows us to point our Jupyter Notebook to the Python interpreter that we want to use. And this would be very similar to us selecting the Python interpreter on this lower right corner when we were trying to execute a simple Python script. What you should understand about kernel is a Jupyter kernel is what you can also think of as the computational backend for the Jupyter notebooks, right? So what you are seeing right here in terms of the code input cell and other options on the toolbar is the front end or web application of Jupyter Notebook. But in order for this code to run, it has to be interpreted and checked and then executed, right? And that work is done on the back end by the kernel. So if you click on the kernel, it will give you an option to select the Python interpreter, right? So we can just select another kernel for now, and then you can select a Jupyter server, but we won't get into it right now. For now, just think of kernel as pointing to your Python environment, right? And if we select that, then it will give us the option to select any of the various Python environments which we created in our previous videos, right? So in this case, again, we'll just keep it to the Python environment which exists within our root project, right? Which is .firstproject.env. So let us select that. And now as you can see, it is pointed to that Python interpreter which exists in our virtual environment .firstproject.env. Right, so now we can execute this line of code, and one of the ways to do it is simply select run all from the toolbar. So if you are running your Jupyter Notebook for the first time, it's likely you'll be seeing this message which is asking you to install IPykernel package. This package is basically the kernel that we were discussing about. That is the computational backend for Jupyter Notebook. So let us install it using a conda command from our virtual environment. So we'll just cancel this. Okay, so let us start the terminal. You can start the terminal from the toolbar itself, or you can use this shortcut Control-Shift-tilde. Always be careful which virtual environment it is pointed to. Currently it's pointed to base environment, so we'll just activate our relevant virtual environment, which would be first project env. And now that it is activated, we'll use this command, right? Conda install IPykernel. Okay. And let us wait for the installation to be done. Proceed yes. Okay, so now it seems to have been downloaded. So let us restart our VS Code for this to take effect. Okay, so let us start our PowerShell and we'll start our VS Code from there. Okay, and our first project was, I think, directly under this CD first project. And this is where we created our notebooks. So we'll go to VS Code using this command, right? Code space dot, and this, as we already discussed in one of our previous videos, would open VS Code from within this folder. Okay, so we'll just wait for the notebook to be loaded, and it will be in the same state that it was when we closed it. With IPykernel installed now, I think we should be able to run the print hello world code that we wrote. Right, you can see that the kernel has already been selected by default now, and we can change it anytime we want to by clicking on this and selecting a different kernel. Right, for now we'll just want to keep that. Okay, so so this is the error we got, that we didn't have the IPykernel package to interpret and execute this code from the backend, right? So we can simply now run it, and this time I used Shift Enter, right, instead of run all to run this code input cell, right? So as you can see, we can see the output of our code under our code input cell, and this would be the code output cell. There is one more kind of cell which is called Markdown cell, right? So you can either create a new Markdown cell using the Markdown option in the toolbar, or you can create it from here. So if I click on it, it has created a Markdown cell. Markdown cell essentially is to document your code, because Jupyter Notebooks, remember, are the tool for exploratory data analysis and visualizations, right? So anytime you are exploring your data and creating statistical or mathematical visualizations, you also can describe what is it that you're trying to visualize or some kind of summary of your analysis using Markdown cell, right? So for example, I can for now just say printing my second hello world, right? And again, I can press Shift Enter, and this is how it will show up. And then I can go ahead and I can print my second hello world. Shift Enter, and it will execute the code and it will display the output in the code output cell. Markdowns are also useful to create superficial documentation of your code that you can use to navigate. So sometimes we might have long Jupyter notebooks with many different cells and many hundreds and thousands of lines of code. In that case, if you go to this lower right corner outline option, you'll be able to see Markdown code is what ends up being your navigating option, right? It documents your code and then you can click on it and it will take you to that collection of cells. For example, if I create another Markdown cell here and printing third hello world, Shift Enter, and then I'll print again, Shift Enter. So in that case, you can see, right, I can navigate to either of this cell blocks using this option. Obviously it's not much useful here because it's just a few lines of code, but it's super useful when you start working on production scenarios. When it comes to executing your code, you can do it either by executing each cell block individually, like we did using Shift Enter, or you can run all the cells at once by using this Run All option. You can clear your cell outputs, and again you can run all the cells. Restarting would basically restart or reboot your kernel, right? So the moment I select it, right, so it's just warning you that you lose all the variables because you're essentially just restarting your code execution, right? So we can just restart this, and you can see on the lower right corner it's restarting the kernel. It usually takes a while. And now that it has restarted, we can run all the code blocks and it will run. You can also use the options on the upper right corner of your cell that allow a bit more flexibility in the way you want to run the cells. For example, if I just want to run this second cell and everything below it, then I can just use this third option here, execute cell and below, and it will do that. Or if I just want to run this one cell above it, then again I can select this option, execute above cells, and it will essentially execute every cell that is above the cell from where I selected that option. Now, when you have a large notebook with multiple cells, and when it's in the middle of execution, you don't it might become very tedious for you to scroll to find out which cell is currently executing. In this case, it's fine, right, because there are just 3 cells and they are executing quite rapidly. But oftentimes it might take a while for your entire notebook to finish its execution, and in that time you want to know which cell is executing without having to scroll all the way up to there. So let me try to mimic that scenario, right? So let me print one more hello world, and I'll print another hello world, and as you can notice, whenever I use Shift Enter, it automatically takes me to the next code cell where I can just continue writing my code without having to touch my mouse, essentially, right? So this would be my 6th hello world. Like, let us create a Markdown cell right up here, right? So we'll just create the infinite while loop so the Jupyter Notebook keeps running. Okay, so we'll just keep printing this. So now let us run the entire Jupyter Notebook. Right, so now as you can see, our cell which runs the infinite while loop is still running. Right now we don't want to scroll in order to find out which cell it is that we are running, so we can just use this go to option displayed in our toolbar. It will take us to the currently executing cell, right? And in this case, obviously we don't want to keep this running, it will just crash, so we can interrupt our code cell using this stop cell execution. Interrupting your cell is equivalent to restarting your kernel, right? So you basically just should clear all the output and restart your kernel once you interrupt a code cell, because it might create issues with your variables. Let us just delete this. We also could have navigated to that cell block which was executing using our Markdown options in the outline. So we'll basically delete the Markdown cell as well. So now let's dive into what I would consider one of the most important topics that you need to understand when you're just starting out with Jupyter Notebook, is how it keeps track of your program, or how it keeps track of your variables, because there are some subtle differences in terms of how Jupyter Notebooks keep the state of your program compared to how it works when you are running a normal Python script. So in order for us to examine the state of our program with this Python script, we can access run and debug option on the left side in menu bar here, and that will allow us to run and debug this Python file. As you can see, the debug console has started. Is also displaying this menu bar which has debugging options in it, and as you can see, the debugger has finished running, but it did not stop anywhere or give us any output variables here. That is because for us to use debugger, we need to give it breakpoints, which essentially are the points in our code where we want debugger to pause the program so we can peek into what the state of our variables is. So we can create breakpoints on this left-sided gutter right besides our line numbers. So let us create our breakpoint at line number 6, 8, and 12. So these are all the points where we have variable assignments. So now that we have breakpoint settled, we can go to run and debug, and we can run and debug. As you can see, our debug console has once again started. It has also displayed this menu bar on the top, which has various debugging options, and we'll be looking at them in detail as we try to understand the state of our variables. So you can see the debugger has stopped at line number 6, which was our first breakpoint, and up until this point the state of our program is right here on the left side, where it gives us the variables output. So we don't have any variables defined. We have not yet defined list. We have imported one module pandas as PD, and that is what is showing up here. And if you hover over it, you'll be able to see that that module has been imported from our virtual environment .first project env. Now from this point onwards, we can either continue, meaning we can continue on to the next breakpoint. So if we click on this, it will go to the next breakpoint, and at this point our variable state is updated to also include list, right, which essentially consists of 3 elements and with length 3. We can click continue, and it will move to line number 12, which is our next breakpoint. And at this point we have updated our variables again with new addition, that of the series which we defined here, right, and that essentially is a date time array is what it is telling us here, right. And then if we click continue, now there are no more breakpoints, so at that point it will simply stop the execution of the program, right. So that is a super quick view of what debugger does. Let us try to make this a bit more interesting by adding some function calls to our code. So maybe right after this line I'll define a new function which I'll just define as random func, and let us define a new variable, say list, right. So it's the same variable but within the function scope, and we can have a for loop here which loops 4 times. So for I in range 1 to 5, and then we can just append those elements in the range to the list variable, right, but this will be the list variable which we defined on line number 13. And at the end of that we will just return the list, okay. And we will want to have another breakpoint here. We'll want to have another variable assignment on this line, and that would be, say, random variable, and it would have the output of random func, okay. And we'll have another breakpoint here, and then we'll just end this code by printing hello world, okay, right. So now that we have our function calls and new breakpoints, let us run and debug our program, right. Again, the debug console is started. Soon you'll be seeing the debugging options on this menu bar, and our debugger stops at the first breakpoint. Now if we select continue, it will go on to the next breakpoint, but if we select step over, then instead of the next breakpoint it will continue on to the next line of code, right. So if I select step over, it will go on to line number 10, and then I can click on continue, and it will go to my next breakpoint, which is where I'm defining this function. Then I can select continue, and it will go to the next breakpoint, right? So at this point in the execution of our program, you can also see on this in the state of our variables, we also have the function variable added, because that is what we define on line number 12, random func. If you select step over, it will go on to line number 19, even though it's not a breakpoint, because that is what step over does. And then we can continue, it will go to the next breakpoint. Interesting feature of debugger is that it also allows us to step into any function calls if we are making a function call in that line, right? For example, in this line number 21, while we have a variable assignment, but that assignment is coming out of the function call. So at this point, if we want to know what exactly is being called in this function, then we can step into that function call, right? So let us select step into. It has now gone into that function call. We can now step over to navigate line by line as our function executes to finally output something into our random variable. We can step over, and it will now start the for loop, right? And an interesting thing is we can actually manually loop through our for loop if we just keep running this option, right? And as you can see in the state of our variables, our local variable, right? And in that case, an interesting point of difference is that our local variables have I as well as list in it, right? But that I does not exist in the global variables, right? Because the scope of this I is limited to this function, which is a local scope. It does not exist globally in our program. And if you look at this list variable, so that variable is also different in the local scope, right? That is the one which we define on line number 13, whereas globally that variable list is the one which we defined on line number 6, right? So oftentimes when you have a huge code base, a lot of this, you have scopes within scopes, right? So a lot of this gets complicated, and a debugger can help us understand as our variables are moving from one scope to another, or what values they have in a particular scope. So now let us keep running our for loop using step over option. So by this time it has gone through the loop once, right? And it has appended 1 to the list, right? And if we again have another loop, then the I variable has been updated to 2, and right, if we keep doing it, it will keep updating, it will keep incrementing I, and it will keep appending it to list till we run out of our range options, right? So now that we have 1 to 4 done, it has exhausted all the options that exist in the range 1 to 5, because 5 is not inclusive, right? So at that point, we are now returning this list to our variable on line number 21, right? And then if we step over, it will move on to the next line of the code, because our function call on line number 21 is done. This obviously is the last line of code. So if I step over, or if I continue, or if I pretty much use any other option here, it will finish this debugging session, right? So that is how you debug. And if you want to like get out of the debugging session in the middle of all of this, you can still do it by simply clicking on the stop option here, right? So you can click on that and get out of this session. So this is how a plain old Python script is executed, right? It is very systematic, top to bottom and line by line. So if my program is on line number 12 of its execution, that means all the previous 11 lines of it have been executed. There is no other way for it to reach line number 12. However, that is not how Jupyter Notebook executes code, right? So for Jupyter Notebook, as we'll see later, it's not line by line execution that matters, but rather it is cell by cell execution. So it is not the sequence of lines that's important, but it's the sequence of cells that you run your code in that would decide what is the state of your variables. So let us look at the example of that. Okay, let me delete, because we have a lot of redundant cells here, so we can just start deleting them using this option on the right upper corner. Right, we can delete the markdown cells also. In fact, let us just copy what we have here so we can actually compare exactly. So we can execute all of this in one cell, but let us break the script down into different cells, right? So we'll import our pandas module here, and then we'll define our list and series variables in this cell, and we'll print our series in the next cell, and we'll define our function in the cell after. Then we'll just execute all of this remaining lines of code in the next cell. Right, so before we begin the execution of our code, let us select this variables option in our toolbar, and that will take us to Variables Explorer. Much like we did in our Python script, we can define breakpoints as well as start debugging session within Jupyter Notebook. But Jupyter Notebook offers this variables option, right, where I like to call it debugging on steroids, because you can observe the state of your variables as you execute various cells in your Jupyter Notebook, and we'll see that. Right, so let us for now just run all the cells, right? And this basically would be exactly like how we ran Python script, right? It would be run top to bottom, and when all the cells are done running, we'll have cell outputs at the end of each cell. We'll also have the state of our variables, right? So list is our variable that holds string elements, which are dates basically, and then there is num random variable, which stored the pointer to your function call, right? So our random variable basically was the output of the function call, right? And then we also had series variable. So we can check out the state of our variables directly using Variables Explorer without defining breakpoints or starting a debugging session. Even if we clear the outputs, it's important to note that the variable values are not cleared, right? And these variable values are basically stored in Jupyter Notebook's cache. Even though we have cleared the outputs, we can still access a variable because the values are still there in the memory, right? So for example, if I print list, it would give me the list element. In order for us to get rid of all the variable values, we just have to restart the kernel. And it also warns us that all the variables will be lost. So let us restart that, and you'll see all the variables would vanish from the Explorer, right? So no variables are defined. Now let us execute our code cell by cell, right? So we'll first execute the first cell. The left side of the cell, you can see, will tell you which order it will tell you the order of the cell execution, right? So this is our first cell, and then this shift enter would be our second cell, third cell, fourth cell, right? So we are still doing it in sequence, like how the code was written in our script. But now let us do something funky, right? So let us, and as you saw, the variables are getting updated as we run code in our cells, right? And at this point, we have not yet executed this cell, right? The last cell, which is why the only variables that we have are list and series. And if we execute the last cell, then we'll have random variable as well as, right? So random variable and num would also be available to us now. So once again, let us restart our kernel, right? And where Jupyter Notebook differs from Python script is that there is no predefined way in which we have to execute our cells, right? So we can execute the last cell first, right? And in this case, it would not work because our random func is not defined, right? So if we just run it, it would give us the error. But say if we just comment this out, right? And at this point, if we just run this cell, then it runs fine. And because that cell had this variable num, that's a variable which we have available in our program at this point in our execution, right? So that's the first cell that we ran. Say this importing pandas module, right? That's a second cell that we are running in sequence, right? So at this point, this is a second cell. Let us run our third cell where we are defining the random func, right? So you can see on the left side, you can already see the index of our sequence, right? So this is cell number 3 in our sequence of executions. At this point, we do have random func available to us, right? Because we have executed it. Let us execute it above random func, right? So it does not matter whether a cell is located above or below the last cell that we executed, so long as it comes after the sequence, right? Because we have already defined random func on execution number 3, we can now use it, right? So our random variable, which was basically just holding on to the output of that random func, can now be used here, and it will run just fine, right? Shift enter. And this is our cell number 4, which is located above cell number 3. And then we can just run these 2 cells, right? So we can just run this cell where we are defining list and series, and then the next cell where we are printing the series, right? So just to drive home this point where we can get quite funky with the way we are executing cells, in Jupyter Notebook, because again, it's a tool not to run sort of production grade Python scripts that we usually run, right? In pipelines or in Azure DevOps or in some other production scenario. But rather, Jupyter Notebook is an exploratory data analysis and data science tool. It allows us to play with it like this, but it's still recommended that you run it normally, right? So even though it gives you this freedom, you still run it top to bottom in a manner that is quite similar to Python script, because a lot of things can go wrong if you run it like this, right? Among other things that can go wrong is if you just delete something, right? For example, if I decide to delete my random func call or my random function definition, and then let me also delete this cell, right? Now, even though at this point, nowhere in my code within Jupyter Notebook am I actually defining my function, but because I've already run that cell and the variable value has been cached into Jupyter Notebook's memory, it is still available to me, right? So I can define another variable, right? So say we're random variable number 2 that takes the output of random func, right? So even the IntelliSense is telling me that it's available, right? So even though it's giving me this yellow squiggly line, so that's my PyLens telling me that there's something wrong in that random func is not defined, but we did define it, we did run it, and it's still there in the variables, right? So we can run this code without any error, and we can print a random variable value. Rather, because in Jupyter Notebook you don't need to print it, it will just output the value of that variable, right? So this works fine, but the problem is if I push this to GitHub repo and then someone else clones that repo and tries to run all of this, it will not run, right? So in our case, it ran because the variables are still there, right? So let us restart the kernel, right? And now if we try running this, it would fail, right? In fact, it failed at the very first point where we were trying to assign output of a random func to random variable. Right, so one thing I always like to check before I push my Jupyter Notebook to a repository is one final time have run all as the command, right? So you can see whether everything is executing in a systematic way or whether you have just deleted some cell after executing it. So that's pretty much it for this video. Obviously, all of this is just the beginning of what you can do with Jupyter Notebooks in VS Code, and as you create more and more projects, you will be learning many more features of it. But my recommendation would be that if you're working with Jupyter Notebooks, then VS Code is where you should be doing it from. Yeah, so thanks for watching.